In this course, Antonio Papa will teach you how to create a microservices project using FastAPI, React, and Redis. Antonio has a bunch of experience with a lot of different tech stacks.
In this video, we will build a simple microservices app using Python FastAPI. The frontend of this app will be in React, and we will have two main microservices. One is the inventory microservice and the other one is the payment microservice. The inventory microservice will store products and the payment microservice will purchase those products. The data will be stored in Redis, so we will use the RedisJSON database, which is a database similar to MongoDB, and we will send events from one microservice to another using Redis Streams. So that is another functionality of Redis. I choose this architecture because we will not use any other database or RabbitMQ or Kafka. We can use Redis for all the needs that we have. Now let's see the app that we are going to build. Also, make sure to check my channel Scalable Scripts, where here I have a lot of projects and more microservices tutorials if you are interested. Now let's move to the app. This is the app that we will build, so it is very simple. We can create products here, which I will create one right now, so I'll call it product. I will set a price and a quantity. When I create, we will have a product created with this ID here, and we have the option to delete this product. So this is the first microservice, and the other microservice is purchasing that product. Here we need to copy this ID, and when I paste this ID, we can see that your product price is $24. Now you may be confused because the price here is 20 and here is 24. The reason that I increased the price here is think of it as another app that buys the products from this warehouse, you can think of it, and on top of that it will add a 20% fee. So it is 24 because it is 20% more. So that's it. When the user buys this product, this app will gain profits, and also the warehouse also. I will buy a quantity of 3. I will buy, and here it says thank you for your order, and if we refresh we won't see it immediately because it needs 5 seconds to update, and now the quantity is 97. So the app will seem very easy, but there is a lot of asynchronous stuff going in the background and also Redis stream events. So we will see it now when we build the backend. Now let's create the projects. Go to fastapi.tiagolo.com, and here we will see the instructions to install FastAPI and UVcorn. After you install these two packages, click tutorial, first steps, and I will copy this code here. Now I will open my IDE, and I have two projects here. So the first one is inventory, where here we will store products and also their quantities, and the payment project where we will purchase those products. So these are the two microservices that we will work in this tutorial. We have a main.py file, which currently it is empty, and the requirements.txt, where we have all the packages that we need, like FastAPI and RedisOM. We will use Redis as a database where we will store our products there, but also we will use Redis as event sourcing software like RabbitMQ and Kafka. So we will use it for multiple cases. Now let's go to main.py, and I will paste the code that I just copied. And to run this code now, simply run the command which is showed here, uvicorn main app reload. So this is the command, and it will run this app on port 8000. Now let's test that endpoint, and to test that endpoint I will use a tool called Postman. So this tool helps us to test API endpoints. I will open the tool now. It is free. I will open a new tab, and I will send a GET request to HTTP localhost port 8000. And if I send the request, we will see hello world here. So we created our first endpoint, and now we want to create a database where we want to store products here. For that, I will use Redis. So go to redis.com, and we need to try the Redis Cloud for free. Now I'm logged into Redis Cloud, and here we need to create a new subscription. So there is a free plan available. I'm located in Europe, and I will select this free plan, 30 megabytes. The subscription name, I'll call it Microservices. And that's it. We created this plan, and now we need to create a new database. I'll call it this database Redis DB. And for the modules, I will select Redis Search and RedisJSON. So RedisJSON is a database just like MongoDB, and Redis Search adds some functionality to search that database, like it is similar to Elasticsearch. And I will activate this database. So the database was created successfully, and as you can see here, we have a public endpoint, which we will use it right now. And we need also the default user password, which we will copy as well. So that's it. Now in this inventory app, I will connect with Redis, and we need to use this package called RedisOM. I will copy it, and I will install it via pip. So pip install RedisOM, and let's import it here. So from RedisOM, we need to import get Redis connection, and with this we will connect to Redis. I'll do it here. So Redis it is equal to get Redis connection. Inside we need to pass the host, which in our case is this public endpoint. I will copy the public endpoint, and I will paste it here. But we don't need the port, so I'll cut the port here, because the port will be another variable. So port here is equal to this value, and then we need the password, which it is this user password value here, which I will copy, and I'll paste it here. So this is my password. Don't use my credentials, because I will remove this connection once this tutorial is over. So you have to create your own credentials. And then decode responses, it is equal to true. So that should be it. We created the connection via Redis, and now we want to create a model that will be converted to a table in the Redis database. So for that, I'll create a class here, product, and from RedisOM we need to import also hash model, and this product will extend from hash model. And let's add all the values that the product has. So the product has a name, which should be a string. Then it has a price, which it is an integer, and a quantity, which it is an integer. Actually, I will change the price. I will make it a float better. And that's it. So this product will have just a name, a price, and this quantity is a quantity available. I will keep it short, so it could be quantity available. but I will just keep it quantity, so I will keep it short. And to make this product connect with our Redis database, we need to add another class here, meta. And inside we will say that the database will be equal to Redis. And that should be it. So with this, every time we query and we create products, it will be stored in our Redis connection. And let's do that. I will remove this endpoint here, and I will create a function products or all, doesn't matter. Let's return an empty list for the moment. This will be a get request to /products, and that's it. So let's test this endpoint on Postman. If we send a get request to localhost port 8000 /products, so we have an error. Is UVcorn running? It seems it's not. And we can see an empty array right now. So it is this simple. Now we need to return the products from Redis, and to do that we have to return products that all underscore primary keys. So this is the function that will return all the products. I will save it, and for the moment we don't have any, but this will return only the primary keys, and this will not return the products. For the moment we cannot see it, but we need to create another endpoint to create a product to see what this returns. We will do that, but first we need to create also a middleware here. So we need to add a middleware called course. Let's import it here. So from FastAPI middleware course, we need to import the course middleware, and we need to add it here. So what is course? So course is a problem that when we run our frontend, it will run on port 3000, and UVcorn here is running on port 8000, so it's not running for the moment. I will fix that. But there are different ports, and the browser will prevent that. In order to prevent that problem, we need to add the middleware. Also, we need to specify the allowed origins. So allow origins here will be HTTP localhost port 3000. So this is our frontend. We need to allow the frontend to request our APIs. We need the methods, so I'll copy this, paste it here. So this is allow methods. I'll put a star here, so all the methods, and we need to allow headers. So that should be it. This won't change anything until now. So the app will work the same, but the changes will be reflected on the frontend. So we won't have problems in the frontend if we add this middleware. And now let's create the other endpoint where we create products. So I'll create a function here, create, and FastAPI makes it really simple for us. First I will add here the method, so app post method to /products, and to create a product we need to pass in the parameters here the product itself as a product, and we need to return product save. It is this simple. So the parameters that we need to send in the request are the name, the price, and the quantity, and the rest will be taken care from FastAPI. So let's see if this works. I'll copy this, open a new tab, I'll send a post request, and in the body I'll send a JSON, I'll send a name, product, I'll send a price, 20, and a quantity available. I'll say 100. So if we send this request, we can see that we get a primary key, a name, the price, and a quantity. So the product was created successfully. And if we try this request again, we can see that we are returning a primary key. But I don't want to return just a primary key. I want to return all the objects, and we need to create another function for it. So I'll create a function here, format, and in this function we need to pass a primary key as a string. So we will pass all the primary keys to this function. We need to get the product, which is equal to product.get with this primary key. So this will query that product from the database, and we want to return the response of this. So I won't display the primary key, I will display directly the ID, which is product.primary key. We need the name, which is product.name. We need the price, which is product.price, and we need the quantity, which is product.quantity. And for this function now, we need to return an array now that will do something here for primary key in product all primary keys. And this something will be calling this format function that we just created, and I will pass a primary key there. So that's it. With this change now, so it seems UVcorn stopped again. We can see now the response is what I wanted. So we have an array of products with the ID, name, price, and quantity. So that's it. We need also one last method, which is deleting this product. Actually, we need two, so I will add the first one. So def get with a primary key as a string. So this will get a single product from an ID, and this will be a get request. Get to products slash the primary key here, and we will return product.get with the primary key. Let's see if UVcorn is running. It is. So if I copy this ID and I will put it here, we can see that we are returning not an array now, but directly the object. So this is working fine. And now let's add the last one, which is deleting this product. So delete here, and we need to pass again the primary key as a string. I'll copy this part, I'll paste it here, and this is a delete method. And we will get the product like this. So product is equal to product get with this primary key, and we will return product.delete. If we try this method now, this will be a delete request. So we have a problem. What is the problem now? It seems that we need a primary key here, so maybe I made a mistake. We should do it like this then. So now it should work. So my bad there. And now it is working. Not sure why it returns 1, but it means it probably means that it is successful. Now if we get all the products, we don't have any. So we created a simple CRUD for the products. And now let's move to the payment microservice. Let's go to the main.py file and let's add all these parts, and I'll paste it here. So we still need the course middleware. We need to create a FastAPI project, and we need to connect to a database. I'll copy this again and I will paste it here. I'll add a comment here and I will say this should be a different database. So the point of microservices is that each microservice needs their own database. I will keep the same database because if we go to the Redis Cloud, if we add a new subscription, let me open it here. Not sure it is here. We need to pay. Still, I have $200 in free credits, but in this case, it won't make a difference since it will be another database. I will use the same database, but keep in mind that this could be not a Redis database, but a MongoDB or a MySQL database. So this is not a problem in what I'm trying to teach you. And now let's create the class for this microservice, what we need to create, and it will be an order. So this will extend from the hash model. And what does the order table has as a column? So it has a product ID as a string. So when we create an order, we need to know which product ID we are buying. And that product ID has a price, which is a float. And this microservice will buy that product with that price, but it will also add a fee. So think of it as you are getting items from a warehouse, but you also need your own revenue, so you add a fee on top of the price that you buy it on that warehouse. And also price plus fee, it needs a total here, which is also a float, the total price that the user pays, the quantity as an integer, so this is a quantity that the user buys, and the status. So this is important. So the status is pending. I will add a comment here. So pending, completed, and refunded. So we will handle all these cases in this tutorial. Pending is when we create this record in our database, but the payment processor hasn't completed yet. This status is when the payment processor approves our request, and refunded is when an error happens, which I will show you later when that error happens and how we will handle it. So we need the meta here, and we need to connect with the database, which is Redis. So that's it. We created also another model, and here let's add the method. So we need to create a function, create. This will be a post request to orders, and we will pass a request here. So we need to import a request. I will import it directly, so I have a lot of imports there. From starlet requests import request. So this is what we want. And then what do we want to do right now? First, we know that FastAPI supports asynchronous requests and asynchronous functions, and I will get the body of that request by awaiting request.json. So this is one way of getting all the data in the request. But I will show you later a better way of handling asynchronous tasks. But for the moment, let's get just the body. And here we will send just an ID and a quantity. And from that ID, we want to get the product and all the information regarding that product. So now comes the first problem of microservices. How do we get that information? That information, we will get it if we request directly the inventory microservice. So we request this endpoint here, and we retrieve that information. And to do that, we need to install another package, pip install requests. So it is installed, and we need to import it here. So import requests. So let's send now a GET request to the inventory microservice. So the request will be equal to requests. We'll send a GET request to HTTP localhost port 8000 /products %s. So this is a string, so we need to pass the ID of the product, which we get it from the body, and that will be converted like this with a %body ID. So this value will be converted to this value. And in the end, let's see what this returns. I will return request.json. And let's see what this returns. So first, we don't have any products. So I'll send again the request here to create another product, which we created. So we can see it, we have a product in the other microservice. We need also to run this microservice, but we won't use the command, so I'll copy it here directly. I'll copy it, I'll run it here, I'll paste it here, but here we need also to change the port because the port 8000 is already occupied, so we'll add port here 8001, and this will run this app on port 8001. And now let's send this request. So we'll send a request to HTTP localhost port 8001 this time /orders. We'll send a post request, and we will send, as we said, an ID, which in our case it is this ID here that we just created, and a quantity. And we will buy 2 products, let's say. Let's send this request, and indeed we got that product. So we are not querying this product in this microservice. Instead, we are sending an HTTP request to the other microservice, and we are retrieving the products from here. So this is one way of microservices communicating with each other. And now we successfully got the product. I will cut this. The product will be equal to request.json here. And we want to create this order. So to create that order, the order will be equal to an order. And let's add all the values that we need, like the product ID will be equal to body ID. We need the price which is equal to this product here, because we don't send it in the request. So this is product price. The fee, this fee will be 20% of the product's price. So this will be 0.2 times the product price. And the total will be the price plus the fee, total here. So this means is 1.2 times the product price. So that's it. So this is the price, the fee, the total. We need also the quantity, which we get it from the request body. And that's it. We need also the status, which the first case is pending. In the end, we will save it. So order.save. So we successfully created an order here. In the end, we will return the order. And the only problem is this status pending, which means that we are waiting for a payment processor to finish in order to change this status. And for that, I'll create here another function. I'll call it order completed. We'll pass the order here as an order. And what we want to do here is simply say that the order that status is equal to completed. For the moment, we will do it like this, order.save. And we will call it here, order completed with an order. So you may ask yourself why I did it this way. So we will make this more complicated, so don't worry. First, let's test if this is working. I will send an order here. Let's send this request. And indeed it works. So we see we have a primary key here. So a new primary key, which means it's a primary key of the order. This has this product ID, this has this price, fee, total, quantity, and in the end it is completed. So this means that it went also to this function, changed it to completed, and it is working fine. But let's say that the payment processor needs 5 seconds to confirm our order. So I will add here time, sleep, for 5 seconds. Usually the payment processor needs their time to confirm, so this is a good estimation. What happens if we add this delay here? If we send another request right now, we will wait for 5 seconds till we get the response. But this should not be the case, because we want to return the order with the status pending, and later on, when it is completed, we want to change the status. How can we do that? So FastAPI supports asynchronous requests like we did here, and for that we need to create a background task. So we need to import, I will import it here from FastAPI background import background tasks. I will also cut time here and add it here, so we have more space. And let's use now the background task, and when we call a function here, I will add background tasks is a type of background tasks. I have also a typo here, and we have this variable right now, and the way that we will use the background tasks is like this. So we will use background tasks, add a task, and our task will be this function here. So I'll cut this name, and I will put it here. If this function does not have parameters, the background task will be simply like this. But this has an order as a parameter, so all the other parameters should be passed after the name of the function. And that should be it. With this, FastAPI will execute this function on the background. And let's see it. Before we test it, I will add also another endpoint here. I will add it here on top. This will be a GET request, because we need to see if the order has changed. So orders with the primary key here. Def get primary key as a string, and we will return order get with that primary key. So we created this just to test it, and now let's test it on the Postman. Now let's send this request. The status is pending, as we can see, but now let's open another tab and let's paste this ID. Now the status, it is completed. So I used 5 seconds to request this, so if I do it faster this time, so let's send this request. I'll copy the primary key, paste it here. It's still pending. Let's wait 2 more seconds, and now it is completed. So as we can see, this is indeed executing in the background. This is how we execute functions in the background in FastAPI. And now let's go to the other problem, which it is that every time we buy a product, the quantity should be subtracted from the inventory. So the quantity here is 100, and we should decrease this value. How do we do that? We will do this by sending events through Redis Streams. So what are Redis Streams? Redis Stream is a messaging event bus, just like RabbitMQ and Kafka. So you can read the documentation here, how it works. So it has a lot of functionalities. I will use just the basic ones, and it will simply let us communicate via different microservices by sending events, and they won't know about each other. How do we do it? We will do it like this. The first step is sending the event to the Redis Streams, and we already have a Redis connection here. And when the order is completed, we change the status of the order, and we will send an event to Redis, and the command is xadd. So this is the command in Redis Streams. We need a key, and the key will be order completed. And we need a value, which in our case I will send directly the order as it is. So this should be a dictionary as well, but FastAPI makes it easier for us. So I will send directly the order as a dictionary like this. So the order is sent, and the other parameter is a star. So this last parameter is the ID of this event. We can put it ourselves as we want, but I want to have an auto-generated ID. So if you want an auto-generated ID, just put a star here, and that should be it. So this is the event that we will send. And in our inventory here, we need to create a consumer, so this will wait for these events. For that, I will create a new Python file. I'll call it consumer here. And in this file, first we need to add the imports. So from the main app, we need to import the Redis connection. Import Redis, and we will import the product. And what do we want to add here? First, I'll create a variable key, which is equal to order completed. And we need also a group, which I'll call this inventory group. And let's create a Redis consumer group. So I will use a try except here. And we will try to create a X group create with the key and the group. So we will create a consumer group with this key and this name. If it fails, then we will print group already exists. So we need a consumer group in order to consume, and now we need to consume. And to do that, we need to add a infinite loop here. So while true, I'll use a try except here as well. For the exception, I want to print the exception, so exception as E here. And we will print the exception as a string, so like this. And inside the try, we will consume, and the way to consume is like this. We'll get the results. Redis X read group. And the parameters here, first we need the group. Second, we need the key. So it is the opposite as creating the group. So we need the key here and the group, but here we need the group and the key. We need also two more parameters. The second one is a dictionary that the key will be our key. So it is order completed, and we need to add this symbol, which means that we want to get all the events here. And the second parameter, the last one, is none. And this is how we consume. I will print the results here, so to see what is the type of content that we are reading. And we need to add a timer. So while we have an infinite loop here, I'll import time here. And we will wait sleep for 1 second. So every second we will consume messages, and that should be it. So now what is left is to run this consumer. I will open a new tab and run Python consumer.py, and as you can see, it is running no search key order completed. So it is running, and this is waiting for the event in the payment part, which we will do it right now. We will send an event when we create an order. Let's send this event, and we should be able to see something here in 5 seconds, because we need to wait that much. And I'm not sure if it is working. I will interrupt it and run it again. So we see an empty array actually. So the message is different, so this means that the key was created. Let's send another event then. We should probably wait 5 seconds till we get the response, and indeed we got, so I will stop it here. And as we can see, we got an asynchronous event from Redis Streams. So this is the order itself. This is the key, order completed. This is the key of the Redis Streams event. and this is the order that we just created. And with this information, we will decrease the quantity by 2 in the inventory microservice. So let's do that. And the way that I will do it right now is first I'll make the condition if results is not an empty array. I will not print more empty arrays here. And then for each result in results, so we can have multiple events because they are returned as a list, and the object itself, so this is what we want. We don't need the key, we don't need the event ID here, we just need this object, and that object will be equal to result. We need the second value of that list, then the first one, then the second one. So this is the way how we get it. And then we will get the product, which will be equal to product get with the object product underscore ID. So this is the ID of the product that we use in the order, and if the product is set, or I will print it directly, so I will do it like this, so print product, then I will decrease the quantity, so product dot quantity is equal to product dot quantity again minus this object quantity, and I will convert this to an integer because it will throw an error if we don't do it, and we will save it, so product dot save, and that should be it. So we get the event through Redis Streams, we loop the results, we get the order, from that order we get the product, we decrease the quantity, and we save that product. Let's see if this works. I will save it and I will run it again, and this time we get the group already exists, but we are not getting empty arrays because I added the if condition here, and we are waiting to send this event. I send this event, so we need to wait 5 seconds, and as we can see, we got a product print here. So it got the product that we want with the quantity of 100. And now if we query again all the products, we can see that the quantity now is 98. So we decreased the quantity asynchronously. So this is how it works. We make a payment for a product, and we send events to Redis Streams to that microservice. This microservice doesn't know what happens in the other microservice. It just gets events to decrease the quantity of the products. So that's it. Our app, it seems that is almost completed. If you look at this app with the functionalities, it seems that everything is handled. But there is a small, a rare problem that may happen, which is in between this time period of 5 seconds. So in between this time period, we may have a problem that if we don't handle it, we will charge customers for nothing, basically. And that is the time when, for example, I will copy this endpoint. I will create a new one, and this will be delete. Now we want to delete this product with this ID. Before I delete the ID, I will create an order for that product, and if everything is successful, within 5 seconds I will delete that product. So let's do it now. Let's send the request for the orders. It is pending. Let's delete the product. if we wait, I will copy the ID of this order. This means that the order was successful because now the status is completed. The customer was charged, the order was completed, but the product was removed 1 or 2 seconds after the order was completed. This means that the customer was charged and the product does not exist. How do we handle this case? So these are rare problems, but if you are building event-driven systems, you need to handle these problems. In this case, in our app, what we will do is we will refund our customers. So we will change the status of the order to refunded, and we will send to the email to the customers that an error happens and your payment has been refunded. And to do that, we need to send an event here to the other microservice. So we will send an event here to the inventory, and now we will send it from the inventory back. And we will do it the same. So I will copy this code, and I will make an if condition here for the product. So I'll do it like this. If the product is set, then we will decrease the quantity of that product. Else, if the product does not exist, so else here, we will call Redis. We need to add, so we need to send another event, which I'll call it refund order. And the order in our case is this object here, which is already a dictionary. So I'll do it like this. So this is the event in this part. This microservice has totally finished. Now let's add the consumer, which I will copy again the consumer here and I'll paste it here to this microservice. Of course, we need to make changes. Here we need to get the order. This is not order completed. This is refund order. The group is payment group. So we need to create the group here, and we need to make an infinite loop. Here we get the order. Actually, the order will be here, or the object. I'll do it like this, object. Then this is the order itself. We will get the order from that primary key, order here, and we will change the status of the order, status to refunded, and we will save the order. And that should be it. So this microservice now needs to call the consumer, so Python consumer.py. It is running. Let's do the same for this other microservice. Let's run the consumer here as well, and let's simulate that problem now. So first we will create a product which was created. We can see this is a product. I will copy the ID, I will paste it here just to be ready to be deleted when we create an order. And let's create an order now. I'll change the ID, send this, and delete immediately the product. So I think the problem now is that the first time the key won't be created. That's why I'm getting this message. Let me stop it now and run it again. So I will try to do it like this then. So in the payment, when we get the order, I'll copy this and I'll paste it here. I'll just send an empty list here just to create the key. And if I get this order, so let's send a GET request. So we have a problem, it seems. Must be a non-empty dictionary. So then I will get the order, and I will pass the order to dictionary here, and I will return the order. I will run it again, and I will stop this. Now it is working, and if I run the consumer, I won't have this problem that the consumer was not created. So as we can see, it is empty here, and now we can simulate the product deletion again. So let's create a product. It is appearing here. I'll copy the ID, be ready to be deleted, and let's create another order, which we have a mistake. So what is the mistake right now? So the mistake is because I forgot to change the ID here. And now let's send the request. It is pending. Delete the product. And now let's see the consumer. Do we print something here? I don't think so. So we don't print anything. But for the order that we just created, let's see it here. And this time I won't send a random event here. So I'll remove this part. I'll just return the order as it was before. I'll save it. And we are still getting completed. So I figured out what is the reason. The reason is this if condition here is not working because when it doesn't find the product, currently it throws an error. So I have to do a try except here also. And we have multiple try catch statements here, but let's hope if this works. Then I will immediately create a product now. I will save this delete request to do it immediately now when we create an order, and let's delete it immediately, and let's see if we get a deletion here. So actually here we don't have any print statements because I removed it. So I added a print statement here on top, and as you can see I retried again with a new order, and we actually get an event. And for this order that I created, I will copy this, paste it here, and let's see if the status now it is refunded. So that's it, how it works. This is a rare case, but anyway, we need to handle also the rare cases in an event-driven architecture. So that's it. These were the microservices that I wanted to build. Now let's build the front end. So now it's time to create the front end, and I'm in the folder now where I have the inventory and the payment microservice. And now I will use the command npx create react app. I'll call it frontend, or I'll call it inventory frontend. And let's wait till it's completed right now. So it is completed. I open it with my IDE. So this is the frontend now, and I have the backends running in other tabs, but we won't change those. Let's work with the frontend. I will remove the test file and this app CSS. We need just our app.js and our index.css. So for the app.js, I will change the HTML here. I will go to getbootstrap.com, click get started, and let's copy the bootstrap CSS. I'll paste it here on the index.html, and for the HTML here, go to examples and go to dashboard. Here, let's view the page source, and I'll copy the code from the container fluid, or from the header, I guess, until the end. And I will replace this HTML here with the one that I just copied. But we need to make a lot of changes here. For example, this table, we need just a table row. We don't need all the other table rows. So from the end until here, I will remove everything. So we need just one table row. We don't need the section title, neither the canvas. I will remove also this div here. We don't need it. For the menu, we have two kinds of menu. So this UL here, I will remove it along with this H6 here. And we need this UL, but we need only one list item. So I will keep the dashboard. And for the header, we don't need this button, this input. We don't need it. And what is left here? So something is wrong, I guess, or not. So let me format it. I'll save it, run npm start, and let's see how it looks like. So if we open it on the browser, it will look like this. Still, we need some CSS because this dashboard has this dashboard CSS here. So in the page source, click dashboard CSS, select all CSS there, and add it to the index CSS here. I'll save it. If we see now our React app, it will look better. Now let's make other changes. For example, the dashboard here, I'll rename it to products. I'll remove this span. And it will look like this. And here we need to render our products. But I will create components. I won't do it directly. So first I will create a new directory, components. And inside I will create a products component. So this will be a JavaScript file, products. And I will export a constant here, products. This will be equal to a function that we will return here an HTML. And that HTML will be this table here. So I will cut the code and I will return it here. So this is the products component for the moment. And for the other HTML that is left, I will create another component. I will call it wrapper, because we will reuse this wrapper to another component. So that's why I split that HTML into two different components. So I'll export a constant wrapper that this will contain all this HTML. In the wrapper, I will return the HTML. So I will remove this class name app and also the div in the beginning. So I'll keep it like this. And here we want to display our products.js. We can do it like this. So I will add here the props. And inside our main div here, I will add props.children. And this wrapper will be used in our products.js because we will wrap this HTML with the wrapper. I'll cut it, I'll put it here, and that's it. So this is our products, is wrapped with this wrapper component, And here we can simply return our products like this. And if we save, if we go back, nothing will change, but our code will look much better. Now let's add the router. So we need to install a package, npm install react router DOM. So this will let us map the routes, so we will have more components. We won't have just the products here. And first we need to import from react router DOM, we need to import browser router, routes, and route. So now this will change this return statement to this. First I will use the browser router. Inside this will have the routes, and for all the routes we need the specific routes. So we have only one route for the moment, which is the path is just the main path, and the element is our products component like this. So if we go to the main path, we will render our products component. I will save this and nothing will change again. Now we are finished with app.js. Every time we create a new component, we need to add a new route here. So for the moment, let's make the products work. So here we are displaying just an HTML, but this should be the list of the products. And to do that, we have to create a variable here, products. Set products will be equal to use state, and the default state will be an empty array. And to get the products, we have to use here use effect, and we need to make a request to the backend. Let's add first the dependencies, which should be an empty array. This means that we will use effect only once if we add the empty array here. And inside I will call an asynchronous function like this, because useEffect does not support adding a synchronous function here on top. It will throw an error. That's why we need to create this. And I created an asynchronous function because now we will send an asynchronous request. So we'll get a response is equal to await fetch HTTP localhost. So HTTP localhost port 8000 /products, and the content, it will be equal to await response JSON. So this is the content. So this content will be our products, and we will call here set products to the content, and that should be it. We added the products here, and we should loop them here. So let's loop the products. So products map product, we will return this HTML where the key, we need to add the key for when we make for loops in React. So the key will be the product.id, and the values will be, actually let's add them first here on top. So the first value is ID, which is correct. Then we need the name, the price, the quantity, and the actions. And when we loop the product, we will display the product.id here. I'll copy, paste it here. This is name, this is price, this is the quantity, and for the actions, this will be just an anchor link. with an href to hashtag. We need to add these class names, which are button, button small, button outline, secondary. And we need to close it, and we will call delete here. And that should be it. So let's see it here. We can see that we are showing here a table. If we inspect, we're calling the products, but momentarily we don't have any products. So we need to create the component to create those products. And I'll create it now. So this will be the products create component. Before we add any code, I will go to the products and I will add a button here on top. And that will be this HTML with the link. So this will look like this. So we have another button here that will navigate to the create page, which will be this products create. And we are using a link here, which we import from React Router DOM, so we can navigate to that page. Also, that page should be added on our routes here, but first we need to export the constant product create, and we need to return some HTML, so we'll return a div here, so we can add it here. So the path now will be create, and the element is product create. So we added the second route. Now let's add the HTML here. So we don't need this div. We need to add here a form. I will add the class for the form. So class name here, margin top should be 3. And for all the inputs, I will use this format here. So we need this class name, and we need an input here. So the first input will be the name. So for the placeholder, I will put here name, and inside the label, I'll put name again. And I'll do the same for the other inputs, which are the price. And the last one is the quantity. We need also a button, so I pasted the button also with these classes and with submit inside. And this form will look, so let me click there, we will go there, and we can see only the form here, which is not correct because I forgot to wrap it with the wrapper. I will add here the wrapper, and I will close it. And if I save it, we can see the form now. We have a name, a price, and a quantity. For the price and quantity, I will make the type here to a number. Same for the quantity. And these inputs now will have these arrows up and down. Now let's make this form work. So for each input now, I'll create a variable. So we need a name, set name is equal to use state empty, and same for the other inputs, which are the price, set price, and this is the quantity, set quantity. And now for all the inputs, when we make a change, so on change here, we will have an event that will set the name to event.target.value. We will do the same for all the other inputs. So this is set price, and this is set quantity. And we got all the values. Now it's time to submit the form. So I will create a function here, submit. And when we submit here, on submit, we will call that submit function. this will have an event, and what do we want to do here is we need to prevent default, because if we don't add this line, when we submit here it will refresh the page, and that is not what we want. So that's it. Now what is left is to send the request to the backend. So we will make this asynchronous, and we will await here fetch. We'll send an HTTP request, localhost port 8000/products, and this time the method will be a post request. We need to add the headers, which are content type will be application JSON, and we need to send the information that we need, which are these three variables here, and we'll send that in the body, which should be a string, so we need to use the function JSON stringify, and the object that we need to send is the name. Will have the value of name, but since they have the same key and the value, I can use it directly like this. So I added the name, the price, and the quantity, and that's it. This is the request that we want in order to create the product. And when we are finished, so if this is successful, I want to navigate back to the products, and we will use the function navigate is equal to use navigate. So y is not imported, so we need to import use navigate from React router DOM. And when this request completes successfully, we will await navigate. I'll pass here -1, which means that go to the previous page. And with this, let's try to create our first product. The price will be 20 and the quantity will be 100. Submit. We redirected back. We created the product. We have an ID here, the name, the price, and the quantity. So everything works fine. We need also to add the functionality to delete a product. So let's add it now. So we have this anchor leak, which does nothing for the moment. Let's create a delete function. I'll call it del because delete is a keyword, and this function will accept, this will be asynchronous, will accept an ID. And if we scroll down, I will add here on click, and when we get an event, we will call delete with the product ID inside. So we have the product ID. Let's go back, and the first thing that we need to do once we delete something is to make a confirmation window. So window confirm, are you sure to delete this record? So every time you delete something, make sure to ask them the confirmation window. And if they type OK, we will await fetch HTTP localhost port 8000/products/the ID that we just passed here. And if that is successful, so we need also to add the method here, which is delete. If that is successful, then from the products here, we have to remove that product. And we will do it like this. So set products to products, but we have to filter. We have to filter all the products that the product.id is different than this ID that we just removed. And that's it. So let's test it now. Are you sure you want to delete this record? Okay, and it is removed. If I refresh, we won't see that record. So we need to create another product with a new price and a new quantity. And it works successfully. Now is time to add the other frontend for the other microservice. So again, this should be another app. So we need to create another React app in order to add the frontend for the payment microservice. But I will still do it in this frontend because it won't make a difference. I already explained the concepts that I wanted to teach you, so adding a new React app won't add anything new to this project. So that's it. With this, I will create a new component here and I will call it orders. And let's export this constant orders. And for the HTML, I will paste it directly. So this is HTML that I want to show there. So to see what it looks like, we need to add it also to the routes. So the path here will be orders and the element will be orders. So don't forget to import that also. And if we open the browser, I will open a new tab here. I will close these other tabs and this is /orders. And this is the checkout form. So think of it as a new microservice. It is the same app, but it won't make a difference if we create a new React app. So here we create the products and here we buy them. And the way that we want to buy them is we will copy here the ID of the product and we will pass the quantity here. So let's go to the orders now. First, let's make for each input, let's make a variable here. So I will add the ID, set ID. This will be equal to use state, empty by default. And we need also the quantity. And this is set quantity. And when we change those values, we change them here. So on change, we will set the ID here, event.target.value, and we will do the same for the quantity. Set quantity. So we got those values and now we need to submit the form. So let's create a function here, submit. Let's add it here on submit. We will call a submit function. This will be an asynchronous function. This will get the event and we need to prevent default. And here we want to send a request to the backend. So await fetch localhost port 8000, not 8000, sorry, 8001 in this case, because we are sending a request to the payment microservice. So this is 8001/orders. This should be a post request. And we need to add the headers. I'll copy them from here. So the headers and the body. And if I go here, I'll paste it here. So the headers are the same and the body is sending this information, but we don't need the name and the price. We need to send just an ID and the quantity. And if everything is set, then I will display a message here. So I'll cut this. I'll create a variable message. Message set message is equal to use state. The default message is buy your favorite products, and when it's completed we will set the message to thank you for your order. And I will show the message here. And that should be it. So this will look like this. Let's try to purchase this product. The quantity is 3. Let's buy the product, and as we can see, thank you for your order. And if we refresh this, we will see 117, so we should wait 5 seconds till this value changes, and everything is working as it should. I will add just a small change, so our app is perfectly working. I will add the use effect here, that this use effect will depend on the ID. So every time we change the ID here, the input, we want to display another message here. So the product price is this much. So I will first make an asynchronous function here. And I will use a try catch, because we may have a problem. In case that we have an error, I will set the message to the same message that was all the time. So buy your favorite product. And if the ID is set, then we will send a message. So request, sorry, wait, fetch to HTTP localhost port 8000/products. So I'll change the quotes here, because we need to use these quotes, because I will pass the ID of the product here. We'll get the content, which is equal to await response JSON. And we will set the message to your product price is in dollars, and I'll put here the value content.price, and let's see if this is working fine. So I will use double dollar signs, because we need an actual dollar sign here. So if I refresh, I will copy this value, paste it here, and as you can see, your product price is $25. So I will make a small change also now. So the price will be equal to, we need to parse it to float, so parse float times 1.2. Since we add 20% in this microservice, so the actual price will be more than that. And as you can see now, your product price is 30. So this is the inventory. We are selling the price. We are selling the product with the price of 25. And in another app that is using those products, we add a fee of $5. So this is how microservices work. And thank you for watching this video. Don't forget to like, share, and subscribe. Thank you.